In this section, we're going to talk about a very important issue, safety. Hello, Scouts. In this section, we're going to talk about safety. I'm going to show you some of the wounds that you can get if you're not careful. I'm also going to describe ways that you can protect yourself. We're going to talk a little bit about grounding and lightning protection and a few other topics. Please pay attention. This is an important subject. We will start by examining this chart. What it basically shows is how little current can do so much damage. It can stop the heart, stop you from breathing, and this is at 100 volts. I might remind you that that's what comes into your house. It's a 120 volt system, and it can do pretty much anything to you. This is an extreme example of what's called an arc flashover. You can see the gentleman in there. He has protective gear on because this is a demonstration, but I've actually seen such a thing happen in a real workplace. The center of this arc is extremely hot, and it will burn, and it's not a lot of voltage that's doing this. So this was a starter example of what can happen. Here we have an example of an electrical hand burn. You can see how deep and how red this is. Now, electrical burns are a lot different than a regular burn because they're normally from the surface down. Electrical burns penetrate deep into the tissue, and because of this, they're far more seriously. As a matter of fact, a doctor who has to treat these is usually specially trained because of the nature of the type of wound. It's deep and it's serious. I hope I'm scaring you to pay attention to safety rules, because this is what could happen. One of the most important things that you can do when you're working with radio is use your brain. Doing things without thought or knowledge can hurt you. I have a favorite quote listed up here. Life is hard. It's even harder when you're stupid. That's by John Wayne. And I want to remind you that just because you're smart and intelligent doesn't mean that you can't be stupid. Here is one of the best rules that you can follow. Never work on a circuit while power is applied. One little slip of a tool, hand, any one of a number of things, and you can get hurt really bad. Okay, now we're going to talk a little bit about outlets and circuits, and generally this is going to be for 120 volt system, residential systems. If you look at these pictures, you'll see on the left one where so many wires are stuck into one outlet socket that the breaker would normally open the current if there was too much current, but what you have here is a real potential for fire. If you don't think that'll happen, I can tell you personally, I saw it happen when I was using a power saw. And when the power saw stopped, I looked to the right where it was plugged into the wall, and the cord was burning. It was actually on fire. Now, there were a couple of other things that were involved in this. For one, the breaker in that system was way oversized. If you look to the right, we'll see a two-pronged plug going into a two-pronged outlet. That's not a problem because the equipment that's probably hooked to is something called double insulated. Today, in the modern circuit of houses, when they're wired, they're required to wire a grounding circuit. And that grounding circuit has one copper wire that goes all the way back to the panel and all the way back to earth. Sometimes when you use equipment that has a three-prong outlet and you can't get it into this two-pronged outlet, they want to use an adapter. As soon as you do that, you have no ground at all. So you must be very careful what you're doing and how you handle the ground. Sometimes in older homes you won't find the three-prong. So be aware that when you use the adapters, and they are sold by the hundreds, they're out there, what you're doing. It's not safe. There is another device called a ground fault interrupter. That ground fault interrupter will sense a ground and automatically disconnect the power. These are great if, and I say if, they are installed correctly, because you have to have a good electrician do that, or you follow the instructions to the letter. If you do not hook those things up right, they will not work properly. There are ways to test those. So you've given a brief introduction to using the circuit in your home. Now the basic idea with grounding is to give the electrical current a path to go to ground. Now in your house you have a little AC outlet plug, and there's two types of wires. There's what they call a neutral, and then there's a grounding circuit. The grounding circuit is hooked into the box and has a copper wire that goes outside the house and is driven down into the ground about 8 feet with that copper wiring. That's the grounding part. So if it's hooked up right, if there's any short, the current's going to go back into that wiring system and back down to the ground. Hopefully not through you. Same way with direct current grounding. A radio operator will add another ground rod and connect all of their station equipment cases to it as well. It provides additional safety grounds, and it will make sure that any stray RF radio frequency currents also go to ground. Then there is the issue of antenna grounding. Use lightning protectants where antennas enter the house. These bleed off static electricity. No protection to a direct strike. However, when we're talking about antenna grounding, we want to be sure to get experts to help us do it right. Okay, this picture shows what happens when you don't have a proper ground. This person was kneeling on the floor with a 120 volt system nearby, and the current went through him, through his knees to the ground. Am I scaring you? I hope so. If it makes you more safety conscious, that's good. Just because the power is off doesn't mean it's safe. In the next slide, we're going to look at a little bit of what a capacitor can do and how much energy it contains. Alright, here's another safety tip. Do not connect power to a circuit until the circuit is finished and you have carefully checked your work. This is very important because it's easy to make a mistake. So double check, double check, double check. That's actually triple check. But you get the idea. Check your work and be careful. Now, if you smell anything burning, what you should immediately do is disconnect the power and examine your circuit to find out what went wrong. And here's the reason why. Small fires get big very fast. Here are some more things to think about. Keep your work area dry. Use safety goggles. You do want to see, don't you? Capacitors hold power even when power is off. You saw a demonstration of that. Cutting wire can send small pieces flying. You don't want them in your eye. Work in a well-ventilated space. Chemicals can be dangerous. Acid fluxes, glues, batteries, all the stuff you use in electronics isn't exactly friendly to the body. And you want to have safety equipment available. Safety with RF energy. Radio waves can burn, so you never want to operate your radio with the cover off. Radio frequencies can cause burns and cancer. If you don't think so, look at your microwave again. Your eyes are especially sensitive to radio frequencies. Very sensitive if we're talking about microwave frequencies. Hams are required to conduct a routine station evaluation to verify safe operation. There are numerous procedures, and the rules for doing this are well documented. One area that deserves attention in safety is antennas and towers. They're usually high in the air, and you want to make sure that they're never located by electrical power lines. They can fall on the line in any direction, never over or under power lines. You could be electrocuted when using that radio. Be careful when you climb. Those towers and roofs are sometimes not very friendly. Every antenna needs lightning protection, and the best way to do that is to find an expert to help you. You want your antenna pole connected to ground rod. You want to disconnect your radios when lightning is in the area. If lightning hits your antenna, it can travel down your lines to the radio. It can also hit the power lines and come in through the house that way. Make sure your antenna and radio are grounded to a good earth ground. Don't operate it in thunderstorms, unless you're crazy. Okay, you now have a lot to think about when you work with radios. And it's time to see how much you've really learned. Get out your workbook and answer the questions on safety. Page 6, question 6.